Welcome to day number 13 of Learn Fusion in 30 days. Today, you'll learn design intent and why it's so important to fully define your sketches. You'll also learn the special way to copy and paste components. 2D sketches form the foundation of parametric modeling. When you create them correctly, they drive your three-dimensional bodies and allow you to change dimensions such as the height, width, clearance, and more. For this demo, you will recreate 2 square washer plates, each with a different design intent. You will then take the Kettle demo file to test your skills at the end. While looking at the first shape, we can ask ourselves, what do we know about this object without knowing the dimensions? All 4 sides appear equal. The edges meet perpendicularly at the corners. The lines opposite each other appear parallel. Our hole appears to sit directly in the center. We can drive all of these important design elements using sketch constraints before we apply a single dimension. Because every design is unique, your approach to sketch constraints will vary. Establishing a clear strategy for how geometric entities relate to one another defines your design intent. Before opening Fusion, take a moment to sketch your ideas on paper or visualize the geometry. This upfront planning makes it much easier to map out constraints that accurately reflect your design intent. Make sure you're in a hybrid design file and save your design. Let's create a new component for the first washer and name it Design Intent Number 1 before you click OK. The design intent of this first example requires the circle to always remain 50% of the size of the outer square. Press R for rectangle and start the sketch on the bottom XY origin plane, as if it were lying on a table. Let's also switch to the center rectangle type in the sketch palette. This option allows you to center the rectangle to the origin point. Remember that starting at our origin point is a best practice. Anchoring your sketch to the origin is crucial for fully defining your geometry, preventing unintended shifting, and creating a predictable foundation for your 3D model. Click to place the rectangle without defining any sketch dimensions. Fusion Sketch Geometry automatically applies constraints. Press Escape to clear the rectangle tool. At any time, you can select the constraint icon, and Fusion will display the name in the lower right corner. Take a moment to look at the existing sketch constraints. The center rectangle creates parallel sides, which covers one of our known requirements. A perpendicular constraint is applied in the corner, which works together with the parallel sides to keep each corner set to 90 degrees. Currently, only the opposite sides remain equal. Let's activate the equal constraint to force all 4 sides to remain the same length, satisfying one of our design requirements. Activate the equal constraint from the toolbar. Very important, be sure to activate equal as the parallel constraint uses a similar icon. Select any 2 adjacent sides. If you try to apply the equal constraint to additional lines, you will receive a warning that this over-constrains the geometry. The existing sketch constraints and our newly added equal constraint will keep the 4 sides equal. Press Escape, then click and drag the edge to test it. This action provides a great way to test the remaining degrees of freedom. Notice you can only increase or decrease the size. The rest of the sketch cannot change. Always aim to apply enough constraints first so that dimensions alone fully define the remainder of the sketch. Activate the Sketch Dimension tool and select any of the 4 edges. Click to place the dimension and define it as 100 millimeters. If you toggle open the Sketches folder within the Design Intent component, you will see a red lock icon. As mentioned throughout this course, this indicates a fully defined sketch. As a reminder, this is always our goal, so you know that a rectangle will now only change if you update the 100mm dimension or if you intentionally delete a sketch constraint. Press C to activate the circle tool and start the circle from the center origin point. Remember, the design intent for the first washer requires the circle to be half the size of the rectangle. Define the diameter as 50 millimeters, and we'll discuss why this approach is problematic. To help visualize this, activate Extrude from the Solid tab. Select the profile and define a thickness of 5 millimeters. Test the design intent by editing the sketch and updating the rectangle dimension to 200 millimeters. Notice the circle no longer measures half the size of the rectangle. The design fails to adapt to our design intent of keeping the circle at 50%. You can fix this by building in intelligence to update the circle dimension anytime that our rectangle dimension changes. Double-click to edit the circle's dimension. Start by selecting the first dimension. Notice it places D1 in the input field, where the number represents the creation order of the dimensions. You can hover over any dimensions to see its number. Fusion allows equations inside the dimension inputs. Divide this value by 2 and press Enter. This calculates the dimension based on the new formula, ensuring the circle always equals 50% of the rectangle. Double-check that everything works by changing the flange length back to 100 millimeters. Notice how the circle updates automatically to 50 millimeters. This demonstrates the power of leveraging sketch constraints and dimensions in parametric design. Although this design is simple, applying these concepts to complex designs allow you to make intentional design changes without the need to rework your files. Let's now create the second test. Click Finish Sketch if the sketch is still active. In the browser, right-click on the component and select Copy. Here's a pro tip. To duplicate a component without linking it to the original, right-click the root-level component in the browser and select Paste New. Unlike a standard copy and paste, which creates an identical instance that syncs all future edits, Paste New creates a completely independent copy that you can modify without affecting the source. Click once to select the component and a second time to edit the name. Change this to Design Intent Number 2. Before completing any work, remember to hover over the component and click the radio button to activate it. This ensures Fusion nests all the following work inside this component folder. The second washer features a unique design intent. Instead of remaining at the center, the circle must always sit 40 millimeters from the bottom edge while remaining vertically aligned to the origin. Double-click the sketch in the timeline to edit it, and let's also turn off the visibility of the first component in the browser. Our circle is currently constrained to the center origin point. Select the center origin and notice that 4 coincident constraints appear. If you carefully hover over each one, Fusion will highlight the related geometry. 2 of these connect to the construction lines, 1 connects to the center of the rectangle, and 1 connects to the center of the circle. Sometimes you might find it challenging to decipher the center of concentric sketch objects. Click the constraint and delete it. Remember, you can always press Undo if you remove the wrong one. With the constraint removed, you can click and drag the circle around freely. Activate Sketch Dimension and click the center of the circle and the bottom edge. Click to place the dimension and define this as our 40 millimeter design requirement. Activate the vertical constraint from the toolbar. Select the center of the circle and the center of the origin to force the circle to remain centered. Before testing this, update the dimension of the circle to 50 millimeters, removing the formula. You can now change your edge dimension to test the design intent. Notice for this example, the 50 millimeter circle follows our goal and always remains 40 millimeters from the bottom edge, regardless of the rectangle size. Comparing these two examples, you can see how leveraging different constraints and types of dimensions gives us different results, while still allowing us to create predictable and manageable designs. To help me gauge if you understand this concept, comment design intent if it makes sense, or comment more if you think we should further discuss this throughout the course. It's now time to test your skills. Click the link below the video to open the Kettle demo file, and click to open it in Autodesk Fusion. Toggle open the Kettle base component, and notice that the side profile sketch is not yet fully defined. Double-click to edit the sketch. To challenge yourself, consider what constraints and dimensions are needed to fully define this sketch if the design intent is to allow the height to change, with the top having a vertical edge. Pause the video and take a pass at it. Here's the solution. Click and drag the blue sketch geometry to see exactly what moves. Start by adding constraints. The top of the tea kettle should remain vertical. You can either apply a vertical constraint, or you can apply a parallel constraint to this line and the center line. Ideally, when two choices achieve the same result, pick the option that requires fewer constraints. The top line needs to sit horizontally for the lid to fit right. You can achieve this by applying a perpendicular constraint at the corner, or by applying a horizontal constraint to the top line. The second option is easiest since you already have the constraint active. If you press Escape and click and drag the top line, only the overall height will move. This means you're ready to define the overall height with a sketch dimension. Add a sketch dimension to the center line, defining it as 170 millimeters. The sketch is now fully defined, and you can now adjust the kettle's height, knowing that the sketch will stay in the correct shape. Last but not least, here are 4 sketching best practices to follow in Autodesk Fusion. Always keep your sketches as simple as possible. Complex sketches cause most of the performance latency in Fusion. Because the timeline does not capture individual actions within a sketch, relying on 3D modeling features makes your design much easier to edit later. Use solid modeling fillets over sketch fillets. Sketch fillets break constraints and often cause downstream errors if you modify the sketch later. Apply fillets to the 3D model instead. Mirror 3D bodies over sketch geometry. Instead of mirroring objects in a sketch, mirror the final 3D body or component. This drastically reduces sketch complexity and improves software performance. Pattern features in 3D as well. Just like mirroring, using the 3D pattern tool runs far more efficiently than using sketch pattern tools, avoiding major headaches when you update sketches later. You now have a solid understanding of how and why to fully define your sketches. I'll see you on day number 14, where you'll practice applying all 13 sketch constraints.